Hey, hello students. Hi. In the previous video, we have seen, continuing the same series, I think in the previous video, you have seen the measures of central tendency. We have a good look. We had a good look on mean, median, and mode. We understood how these three function. Okay. Now, but we also saw in the last video that to understand the data, only the measure of central tendency, right? The measure of central tendency, I'll just write it over here. Central tendency, this is insufficient. This is what we have seen in the previous video, that this is insufficient, right? So this is insufficient to understand the data. Now we have a database over here. We are trying to understand that data. Okay, we like to understand what we need is a basic level of, okay, this is what is the data set, and we can take a decision based on that. For example, we've taken a example of all the people buying, let's say, Oreo. Okay, if I collect the ages of all the people who are buying Oreo in a certain locality, and I've collect the age over there, we've found that central tendency is might ditch me, might actually give me wrong inclination towards something. For example, if I just repeat those two examples that we have taken, let's say if I taken 12, 13, 14, right, 22, 24, and let's say 25. Okay, let me try and do this. This is again this is -7. I'm just taking it. What I want is there are 7 quantities, and I'm trying to make an average over here. Let's see what is the average of these 7. Okay, so it'll come out to be 24 plus 27 makes it like 51, and then we have 51 plus 22 makes it 73, 97, 102, and 122. So basically it's 122, and I think 19 6 is 114. I'll take another quantity over here to ensure that we get to let me take 11 over here. I hope we get it up. So it'll come out to be equal to, I think 122 plus 7 is 133. If I just calculate the average of this group, it comes out to be 19. Okay. Now let me take up another group over here. Let me take up a group of, let's say, 16. Right, 16, we have 17, we have 18 over here, then we take 20. Okay, we take 21, we take 27. Right, I'll just try and calculate this. I'm just taking another 8 numbers over here, which comes out to be I want to bring the average down to the same thing, that is 19 over here. So I'll see -3 -3 -2 makes it -8 -9. -9 plus 1 will be -8, plus 2 -6, and plus 6. I think it comes out to be equal to something like this. So I'll go for another 15 over here. Let me sum it up quickly. It'll be 32 plus 32 makes it 64, makes it 74, 82, 102, and it comes out to be 148. And then we have around 8 quantities, and 148, I don't think the average comes out to be equal to this thing. So if I just do a bit of calculation, right, what I want to do is to make an average 19 over here as well. So if I go for 19 times 8, it comes out to 72 plus 80, 152, right? And we have a sum of, sorry, I forgot the sum again, 64, and it comes out to be 82, 102, and 148. So what I needed was basically another 4 over here. So let me try and make another quantity 19 over here. That is fine. What I'm trying to say over here is the average of these two groups, both of them will come out to be 19, right? But if you look at it, both of them, 19 doesn't really belong to this group because none of the quantities are really close to 19. Whereas 19 as an average belongs to this group because a lot of quantities are very close to 19. Point is, central tendency may not be sufficient to understand the data. Then what is the next thing that we need, right? What we need is measure of dispersion. We need measure of dispersion. What is dispersion? Dispersion is nothing but how much spread is my data. Now if I look at this data, okay, if I look at this data, the data looks something like this. I'll draw it over here, right? So these are all dots. The dots are, right, these are all my 1 2 3 4 5 6 7 and let's say 8 points. And let's say this is my mean of that. This is my central tendency. Now if I look at this data appears to be something like this: dot 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 How many of them? Just one more required. I'll just make it like this. And if I look at the central tendency, the central tendency probably lies somewhere over here. Agree? Now, if I look at it, this data set, they have a difference over here. The central tendency can really be called a central tendency, and we can say that the average age of this bunch of number comes out to be 19. And we can say that almost every number is in or around 19 except 27 in this case. Whereas in this case, the data is slightly more spread, and we can say that the central tendency perhaps may not be a good representative of the entire data. That's the point. So what we need to do is we need to find out that how much is, how much is this spread across, right? How much is every point deviating from its central tendency? I think that is called as dispersion, right? How much is every point deviating from the central tendency? Now, if I somehow get a calculation of that how much is every point deviating from central tendency, we might get an idea about how much is spread the data is, right? Now, if you look at it, I'll just remove this calculation from here. Yeah. Now, if I look at it, dispersions can be measured in many ways. For example, there are many ways in which you can calculate measures of dispersion. One of which is pretty simple. I'll just keep it like this. I'll probably go for the blue color. I'm talking about mean deviation. Right. I'm looking at quartile deviation. And I think I'll just consider one more thing that is called as range. People do look at range of the values over here. Then we have something called as variance. And finally, we have standard deviation. These are all the statistical measures or statistical parameters through which I can easily measure how much dispersed or how much spread the data is. Okay, let me look into it. Now let me start with something which is slightly on the easier side, range, and probably then I'll move on to quartile deviation. Let me move on to another sheet. Okay, let me move on to the first definition that has been discussed over here till now. I think that is range. Range is nothing but the maximum quantity minus the minimum quantity. Maximum minus minimum. That is the range over here. For example, if I take again the two things, if I recall it properly, I think the values were 11, 12, 12. Then we have 13, then we have 14, let's say we had 21, then we have 24 and 27. Let's say whatever the average is over here. And then we have something like 15, 16, 17, 18, then we had 20, and then we have 23, and let's say another quantity, 27. Let's just take in the case over here. Now, if I want to understand how much spread is the data, generally what I do is, if I just calculate the average of this one, 11, 12, 12, I think it comes out to be equal to 35 plus another 27, makes it like 62, 107, 114 and 20 is equal to 134. 134, and how many quantities are there? 8 quantities are there. And I think if I want to make it an average of 17, I'll just do a bit of calculation over here. 17 times 8 is 56. I think it comes out to be 126. 18 times 8 would be more closer over here. I'm trying to make the average of this group 18 to prove a point. So it'll be 64 plus 144. I think I'll increase one of the quantities by 10. Let me make it 37. Right. And I'll get the average of this to be 18. Let's try and keep the average of the same over here. It'll be equal to 31, 48, 58, 66. 86, 89, and it'll be equal to 109, and 27 will be equal to 136, and I wanted it 134, so let me make it 25. Okay, the average of both the groups comes out to be 18. Now if I take the range, the maximum over here is 37, the minimum is 11. The maximum over here is 25, the minimum is 15. Now this also proves that the range also might not be a great idea, because 37 minus 11 is going to give me what? 26. 25 minus 15 is going to give me 10. The mean is same, but the range is different over here. Again, maximum minus minimum doesn't give me anything when it comes to understanding the dispersion of the entire data, because the data might be something like this or might be something like this. Range is also insufficient because the problem with range is if 11 and 37, both of them, in this case, how is it happening over here in this particular type is that both of them are actually my outliers. So if range in maximum and minimum or any one of them becomes the outlier in the data set, the range will be exceedingly high as compared to, so which means that the data is like spread across 26 different points with a mean of 18, right? Now the data might be this, the data might be this, the range is coming out to be two different things. The range is completely different over here. So if maximum and minimum are outliers of the data set, the range will give me again a wrong inclination. Range alone is not sufficient. Range probably will work when the data points are close to each other. They're close enough to each other. Then we come to another definition called as quartile deviation. Now we need to understand this quartile deviation. Okay. Now what quartile deviation does is it says that let's arrange the data in the ascending order. Arrange the data in the ascending order. So these are all my data points. Okay. I'll draw the dots over here. These are all my, or let me do it like this. This is my data. All of them are my data points. Okay. I've arranged them in the ascending order and so on like this. The data goes like this, and this is my entire data, right? So this is my minimum value, and this, let's say over here, is my maximum value. Let's say there are 100 data points over here. Okay, I'm not just taking 7 to 8. There are 100 data points. We might take it as 10,000 data points as well. It can be anything. Now this is my minimum value. This is my maximum value. Now I define 3 points over here. One is 25th percentile. Please make a note that I'm not talking about 25th percentage. I'm talking about 25th percentile. Another point over here which is like 50th percentile, and then we have another point over here which is 75th percentile, right? 25th percentile. Let's understand this particular term called as percentile. Percentile is nothing but the percentage of data below that particular point. Okay, let me take up a case over here. Let me take up, let's say the minimum value is 107 and the maximum value comes out to be 783 of a data set. Let's say the price of all the products that I'm selling. Now 25th percentile, if I look at the arranged order over here in the ascending order, minimum is 107. Let's say I come across another value, something like 129. Now I say that 25% of my products, 25% of my products were having price less than or equal to 129 per unit. So 129 comes out to be the 25th percentile in the arrangement of the prices of all my products. Similarly, if I say there's a point over here which is like 317, then 317 is my 50th percentile, which means that 50% of all my products which I'm selling are less than or equal to 317. That is 370 is my 50th percentile, or if the data is arranged in order, is my mid value. Okay, that's the point over here. It's my mid value. Similarly, somebody might argue that okay, 612 comes out to be just take random numbers taken over here, guys. No calculation involved. Okay, which says that 75% of my data is below 612 or equal to 612, right? Only 25% of my data is between 612 and 783, which is the maximum value over here. That's the point. It's not 25% or 25% of the range or anything. These are simple points below which 25% of the data or 50th percentage of the data or 70% or 75% of the data lies. Quite clearly we understand that this is my median. This is my median. Can I say this is my median? By median, what is median? Median is the mid value of the data. So if 50% of the data is below or above this, which means that this is my median, this is not my mean. Okay. So this particular element over here, right? This particular element over here, I'll just make it green, is called as Q1. This is called as Q2 and this is called as Q3. So Q1, Q2 and Q3 are three quartiles. 25th percentile quartile, 50th percentile quartile, and 75th percentile quartile. We define something called as IQR. IQR stands for interquartile range, which is nothing but Q3 minus Q1. So from range, we have moved to this particular approach. And how is this approach slightly better than range? It neglects the outliers. Can I say this? Even if maximum and minimum are my outliers, I'm not looking at maximum or minimum. I'm looking at 25th percentile and 75th percentile as well. Right? So a better approximation of the spread of the data as compared to range. Okay. And in this case, it will come out to be equal to 612 minus 129, which will be equal to subtract 130. So subtracting 100 is going to give me 512, another 20 is going to give me 492, another 9 is going to give me 483. So it comes out to be equal to 483. Right, that comes out to be my case over here. Okay. Right, so 483 comes out to be interquartile range, right, where the mean is something. I haven't calculated mean in this case, but mean would be something probably close to the median itself. But if you look at it, interquartile range is slightly better than the range itself, IQR, right? Why is it better? Because first of all, I repeat, it neglects the outlier. Secondly, it's trying to consider the entire data in itself. But that is also the disadvantage of quartile deviation. The disadvantage of quartile deviations is, I'll just probably write it somewhere over here or probably over here, right? It doesn't consider every point in the data. It's definitely correct that IQR is a better approximation than range to calculate the spread of the data, but it doesn't consider each and every point. It just considers 3 points in the data somewhere. And although it's better, but still not the best way of understanding the spread of the data. Now, the best way of understanding the spread of the data, the methods which cover each and every point, which consider each and every point and their distance from mean, are called as deviations: mean deviation, standard deviation, and variance. Let's see them in the next video.